I got the great privilege as the Minister for Science of seeing all the science and technologies that we're doing here in Britain, and we are still world class. We're still a world leader. And our experts have been identifying 8 particular technologies where Britain clearly does have a world lead. And the first is data-driven science. Increasingly, we're going to be using powerful computers to analyse very large amounts of data. And in Britain, we've got some fantastic data sets. After all, we've been collecting patient records in the NHS. We've got continuous meteorological records going back to the middle of the 17th century in the Midlands. And we've also got, with great people like Alan Turing, people who've written the software that enables large data sets to be analysed. And I'm very much hope that at Jodrell Bank and in Manchester, we will, for example, be leading the analysis of all the data that will be coming from one of the world's biggest radio astronomy experiments ever, the Square Kilometre Array. 3,000 dishes in South Africa and Australia, collecting a flow of data greater than the current flow of data across the internet. And it's going to be analysed by British computers using British software based in the Northwest. So high-performance computer and data-driven discovery is the first great technology. Secondly, when you're looking at another source of exciting data, space, satellites, incredibly powerful collections of data now. In the old days, when people used to do global weather forecasts, Royal Navy ships chugging around the oceans would drop a bucket over the side and would take some seawater and would stick a thermometer in and would radio back what the temperature was. Now we have got satellites that, using highly sophisticated sensors and the exact infrared radiation coming from the sea, will deliver millions of ocean temperature readings a day that they can feed in to the Met Office to understand global weather patterns. In fact, the Met Office currently has more data than it has the computer capacity to handle. But using satellites and applying data collected from satellites and from space to understand what's happening to our world. Again, Britain very good at all this, not least because we're actually world leaders in small satellites. In Surrey, in Guildford, we make 40% or more of the world's small satellites that are the size of a football or less. Then thirdly, we've also got very important challenges in software in order to create the autonomous systems and the robots of the future. And robotics is very exciting, but robotics is really dependent on high-performance IT systems, because if you think about it, when the robotic arm reaches out for the cornflakes packet, one thing it has to do is get the pressure in the digits correct so it doesn't crush it or drop it. That's one software program. There's a completely different software program so that when the disabled person lying in bed says, go to the kitchen and collect the cornflake packet, it can successfully identify the cornflake packet and not confuse it with the Weetabix or the Sugar Puffs. So that's a different software program. And we're very good at that. And if you go to places like the robotics labs at Bristol, you will see incredibly exciting things happening in robotics. If you go to the University of Hertfordshire, you will see humanoid robots being used to help autistic kids relate to the wider world. If you go to Oxford, as I have, you will sit in a driverless car and go driving around a research park without the driver touching the steering wheel, because that car is using sophisticated data handling and software to analyse information about its environment. So robotics and autonomous systems, another great British technology. Those first 3 are kind of dry IT-based technologies. My next 3 come from the life sciences. And of course, another great British discovery, the structure of DNA, tells us that our genetic information comes in digital form. And it's incredibly handy that it comes in digital form just when we've got the IT explosion and this surge in the capacity to handle data in digital form. So I guess 4th on my list of great British technologies will be the different ways in which we use genetics, including in synthetic biology, where we start to try to create organisms that will meet a particular need, or a bug that will eat waste and convert it into bioethanol or whatever. So 4th is synthetic biology and genetics. 5th, sticking with the theme of the life sciences, because Britain is a world leader in life sciences, is regenerative medicine, growing the cells that we need to heal us. And I have seen in a on a Petri dish in a lab at Imperial College or their research centre out in West London, I've seen heart muscle cells being grown. And when they go above a critical mass, they start pulsating as if they're a heart. So you ask the kind of Michelangelo Sistine Chapel question. So did you have to put an electric charge through these? And no, if you've got living cells, if they're growing, as they grow, when they go beyond a certain amount, these heart muscle cells will start to beat. And of course, the medical challenge for the future, and we have got some great research centres, including the Catapult Centre in Guy's Hospital in London, is to grow cells that will enable the body to repair itself, to inject these cells into the body so that broken nerve connections can be repaired or hearts can be repaired. It's a really exciting research project, and Britain is up there as a world leader. And then, although those examples are both that's a human medicine example, we shouldn't forget agricultural science. Sometimes overlooked, but Britain has some of the world's most long-lived continuous scientific experiments have been in the agricultural sciences. There are fields in Rothamsted where they have been growing wheat in controlled conditions for over 150 years and keeping the results and recording the results and drawing on them to improve strains of wheat in the future. And we've set the target, we call it the 2020 challenge, because at the moment you get from a hectare of land, on average, an English field, you'll get in a good year about 11 tonnes of wheat. We want to grow 20 tonnes of wheat from one of those fields. That requires sophisticated science. It involves understanding exactly the best fertilisers to use. It involves breeding the most productive forms of wheat. So agricultural science is the sixth great British technology. Then my last two are slightly different. I mean, seventh on the list is all the challenge of energy, and there are so many different challenges in the energy field, but one of the crucial ones is energy storage, and that comes at different scales. I mean, partly the personal computers and mobile phones we have, mainly using lithium-based batteries developed in Oxford in the early 1980s, but commercially exploited by Japanese businesses because we didn't apply British science as successfully as we could have done. We're going to learn the lesson from that, and I hope we can raise our game on that. But the next generation of efficient, low-weight, small personalised batteries, that's one challenge, going right through to the different scale of renewable energy sources, tidal power, wind power. They don't, at the moment, come with a battery attached. They can only use the electricity whilst it's being generated. Are there better ways of storing that so as to make those more efficient energy systems? That's another area where Britain has got a strong position. And then eighth on my list is advanced materials, increasingly developing the materials that we need for other modern technologies to function, the materials that you put into a turbine blade of Rolls-Royce, which is in the great tradition of British materials science. That's what Pilkington glass was all about. It's what Wedgwood, the potteries were all about. So there's a great British tradition of trying to develop new materials. And I think it's going to be crucial for our great aerospace industry. Remember, we've got the world's second largest aerospace industry. It's very important for Formula One motor car racing. It's going to be increasingly important in a range of applications. And so I think advanced materials and research in advanced materials is important, and look at the way in which the discovery of graphene by the Nobel Prize winning scientists at Manchester University caught the imagination. So you put that together and you've got technologies harnessing data and IT, you've got technologies in the life sciences, you've got energy efficiency and energy saving technologies, you've got advanced materials. They're all areas where I, as a layman, see exciting things happening in the labs, in the business research centres of Britain. And I think the more we can excite young people with how great we are and what the opportunities are, the more confident we can be that Britain is going to carry on generating great technologies in the future.